You lie awake at 1 a.m. watching a documentary about blue whales on National Geographic. You find out that they are the largest creatures on Earth and that they have the longest mating dance in the world. Great, that just ruined your Wednesday night. What on earth is this? Where are your parents, Kyle? Jeez, I knew you were lonely, but it's getting out of control. You know what? Since you are so interested in suspiciously large things colliding, let me show you what happens when we collide the largest known things in the universe. Yes, we are going to collide the largest stars, the largest black holes, and even other cosmic objects so large you won't even believe they are real. Starting with the largest planets in the universe, HD 100-546b and HAT P67ab. Now, when I say the largest, I really do mean the largest. HD 100-546b is not only one of the largest planets in the entire universe, coming in at around 7 times Jupiter's radius, but not only that, it also orbits a baby star just finishing its formation. You know what that means? It's an early solar system, meaning it's primed for a lot of colliding with each other. But having this large gas planet collide with a pathetic rock would be kinda boring. So what if we collided it with the second largest planet in the universe, HAT P67ab? Well, this planet is a lot smaller than HD 100, but it is still over 3 times larger than Jupiter. We are also assuming that their masses don't make them brown dwarfs, which is possible, but we're not here to consider that, we're here to collide them. And they would probably collide at around 216,000 kilometers per hour. That's like me speeding through residential areas when I'm late for dinner. And due to the huge hydrogen-helium atmospheres from these massive planets, those would begin touching first. What does that look like? The planets compress and ionize, which means they charge up particles with more energy, and then heat each other up to thousands of degrees. Shockwaves would tear through both planets and eject vast arcs of hydrogen and helium into space. That includes a bright flash of plasma visible in infrared. You know, the type of stuff you only see with night vision goggles. Absolute cinema. But then, after all these outer layers have collided, it's time to smash their solid cores together. Both cores make their way through all the remaining gas and then crash into each other, forming a new supercore. Most of the outer layers of these planets would escape, while the rest would get caught up and collapse onto the new supercore. And you know what that means? It would literally make a new planet. And if this total mass is above 13 Jupiter masses, like if they actually are already that way, you have guessed it, we'd have an actual and real brown dwarf. Which, by the way, isn't really brown, just so you know, but they are though. But you know what? Who cares about planets turning into a brown dwarf or not? It's time to level up a bit, because next up are the biggest stars in the universe. In fact, the actual largest confirmed that we've ever detected from Earth, VY Canis Majoris and RSGC1 FO1. VY Canis Majoris is a red supergiant 1,420 times the radius of the Sun. It's so obscenely massive that it would stretch out past Saturn if it were to be in our solar system. However, it's not just its size that's incredible, it's also highly unstable. This star has been losing mass for centuries because as stars get larger when they age, gravity can't contain their outer layers the further out they get from the core of the star. Because of this, it's close to going supernova, but not before we collide it with RSGC1 FO1. This is the largest known star by radius, sitting at around 1,530 times the size of the Sun. It lives in a tight little death cluster of other doomed giants called RSGC1, like a galactic retirement home full of elderly people enjoying their final days. The only difference is that grandma doesn't go supernova. Now, if these two old stars somehow slammed into each other at relative speeds of, say, 300 kilometers a second, here's what would happen. Their outer layers, mostly hydrogen, would collide first. Not violently, just slowly puffing into each other like two smoke clouds trying to start a fist fight. The atmospheres compress, heat up, and partially ionize into low-energy plasma. Nothing explodes right away, but they kinda do look like Siamese twins at this point. And then, deep inside, their cores finally meet. Well, eventually. Both stars are in the late evolutionary stages, which means they've likely built up cores consisting of heavy elements through fusion. You know, helium, carbon, and maybe even oxygen. This means that when their dense cores collide under massive gravity, it's a disaster. The combined mass easily exceeds the threshold for stability. Gravity wins. It always wins. The result? A complete core collapse, but only for the larger core that has already begun absorbing the other. the temperature spikes past 3 billion degrees, and the atoms inside literally start falling apart, as in the nuclei get ripped into pieces. This releases a flood of neutrons into the core. The core itself collapses from the pressure, and the whole thing blows itself apart in a special type of supernova. The duration of this entire event? Less than a second, which is interestingly enough also the exact amount of time my ex-wife took to make up her mind about divorcing me. Now that's what I call a fun fact, and definitely not traumatizing in the slightest. But 20 years of relationship marriage counseling aside, the outer atmospheres of these stars would be blasted outward at thousands of kilometers a second, and the combined dead core most likely will form into a black hole due to the insane mass. And now that does remind me of something, Kyle. We've collided planets and stars, but what if we collided the largest black holes in the universe? And now we know black holes do contain information as hair, unlike your mind, Kyle. Until today, because this video's sponsor is Brilliant. This is my go-to app for actually learning science without needing to actually witness the largest things in the universe collide. Brilliant helps you get smarter every day with thousands of visual interactive lessons in physics, astronomy, math, programming, data analysis, and even AI. But even more than that, Brilliant helps develop a daily learning habit, keeping you on target for your learning goals, both professionally and personally. Because the app is available on mobile and PC, whether you're in deep space or lying in bed, you can level up your intellect quickly. Lately, I've been loving the Mind Workout. These daily interactive courses across a wide range of topics keep me sharp so I can always come up with ideas for our adventures. And yeah, for that you need your coding and your Python and your data analysis and your science. To learn for free, go to brilliant.org/gravipool, scan the QR code on screen or click the link in the description. Brilliant's also given our viewers 20% off an annual premium subscription, which gives you unlimited daily access to everything on Brilliant. Now we are ready to collide some black holes. Not those tiny baby black holes, no. The biggest black holes we've ever discovered. TON 618 and Phoenix A. But here's the thing with TON 618. It's not just a black hole. It's a supermassive gosh darn vacuum cleaner at the edge of the observable universe with an estimated mass of 66 billion suns. Meanwhile, Phoenix A lives inside the legendary Phoenix cluster, and this beautiful gentleman is not a gentleman at all. He's a massive 100 billion solar mass black hole that makes TON 618 look tiny in comparison. It's a unique one because it's still actively feeding, like a malfunctioned cat feeder. So what happens when two of the heaviest objects in the universe smash into each other? First, they don't crash right away. They would start doing this ultra-slow death spiral where they orbit each other for billions of years, leaking energy in the form of gravitational waves, which is basically space-time screaming quietly. As they get closer, their speeds spin up. They start dragging everything around them into chaos, and space itself begins to stretch and flex like a rubber band about to snap. Then their edges, called event horizons, finally touch. The two black holes merge into one mega black hole, but for a split second, it's not even round. It's this stretched, wobbly, distorted mess of pure gravity violence, like a jellyfish having a meltdown when it eats one of its own kind. Yikes. This merging moment releases more energy in invisible gravitational waves than all the light from every star in the visible universe combined. Except, of course, you can't see it. Only a special Earth detector called LIGO or aliens with giant gravity ears could detect it. And yes, Kyle, your ears come suspiciously close. And what's left? A new, even more massive black hole. Phoenix 10 618A or some bullshit like that. These astro guys always have the worst names possible that I have to say out loud. Now, what could possibly be larger? Turns out we can really up the extremity to a level hitherto unseen. And I'm talking about one of the scariest, baddest, largest, and most unnatural entities this universe
has to offer you nightmares.
Two of the largest galaxies in the universe. First up, UGC 2885, also nicknamed Godzilla's Galaxy. And that should already tell you enough about what we're going to get into. It's about 2.5 times wider than the Milky Way, stretching across 800,000 light years, possibly, and it's got at least 10 times more stars than our galaxy. Maybe. But somehow still has a spiral like the Milky Way itself. Definitely. It's the quiet tall kid who never speaks but could beat up the whole class if he wanted to. And facing it, ESO 38376, a super giant elliptical galaxy. This thing is a galactic sponge. It's already absorbed multiple smaller galaxies and just kept going like nothing happened. Think of it as the final boss of cosmic cannibalism. It spans over 1 million light years with a massive chaotic halo and a fat central bulge stuffed with stars and dark matter. Imagine stuffing your bulge to make it look bigger. Couldn't be me. Now, imagine these two smashing into each other at hundreds of kilometers per second. First, their dark matter halos collide, distorting space itself. Then their gas clouds actually crash, igniting starburst regions, a place where millions of stars are born, with maybe up to 1,000 solar masses a year. For comparison, the Milky Way does, one solar mass a year. So 1,000 is a lot. The spiral structure of UGC 2885 would get torn to shreds. ESO 3876 doesn't even flinch. It would just eat up the Godzilla galaxy. Ironic. The black holes at their centers spiral in towards each other like a gravitational blender set to obliterate, and after billions of years, a new supergalaxy emerges. Smooth, elliptical, featureless, and utterly dead inside. Like how you feel after watching those whale documentaries, Kyle. That can't really be good for your mental health. Anyway, we've smashed stars, planets, and galaxies. How could we possibly go even larger than this? Well, galaxies can sometimes exist in clusters, and the two biggest ones are the Phoenix Cluster and El Gordo, which literally translates to the fat one. Interesting. The Phoenix Cluster has at least 42 galaxies, over a quadrillion solar masses, and a black hole that's still eating in Phoenix A, as we have discussed before. And gas flows around this area are so intense they literally cool and collapse into more stars every day. It's violent, bright, and honestly, kinda hot. El Gordo is about the same mass, but way more violent, as in the collisions of all the 167 galaxies are at about 3,000 kilometers per second moving, compared to Phoenix Cluster's only 1,000 kilometers a second. So what happens when you take two clusters, each with hundreds of galaxies on average, trillions of stars, and an unimaginable amount of dark matter, and slam them together? You get something insane like 10 to the 58 joules of energy ridiculousness. All you need to know is that that's more energy than all the previous collisions combined. Galaxies get ripped out of orbit, black holes slingshot across intergalactic space, gas clouds crash and light up in X-rays hotter than the core of a star, and the dark matter just casually passes through like nothing happened. Because of course it does. It always does. This isn't just destruction of galaxies or intergalactic gas lighting up like fireworks created by Odin himself, but it's the loudest silent event in the universe, like a silent disco in space where everyone sings at the top of their lungs. But listen, Kyle, how do we make this even larger? I need larger. What could possibly be bigger and larger than the largest of the largest galactic clusters? Filaments, Kyle! Filaments! Imagine the universe as a gigantic 3D spiderweb made of dark matter and gas. Yes, literally this. That's what cosmic filaments are. They're the highways of the universe. Vast strands of galaxies, galactic clusters, and everything else in space, all connected by gravity. But then if that's all connected, what are the absolutely biggest of the biggest structures in the universe that we can collide? I'm glad you asked. First, the second largest, the huge LQG. And no, that is not the newest LG TV. Instead, it's 4 billion light years across, 73 quasars in one filament, each brighter than any galaxy. It's like an ancient monster that was born when the universe was a toddler. It's organized, compact, and active. Each quasar has a black hole that is eating and shooting out jets of radiation at 99% the speed of light. But the largest structure that we know of in this universe, the Hercules Corona Borealis Great Wall. If you thought 4 billion light years was a lot, well, this one is 10 billion light years. A gigantic filament-like structure made not only of clusters of galaxies, but superclusters, quasars, and billions of other random galaxies. It was discovered by mapping the most powerful explosions in the universe, gamma ray bursts. If you could see this from the outside of the universe, it would stretch across 1/10 of the observable universe. How insane is that? Its existence shouldn't even be possible and violates the rules that the universe should be evenly spread out at large scales. You know, homogeneous. Of course, a collision is very unlikely to happen, but then again, so is their existence. However, defying the expansion of the universe, let's smash them together anyway. It would take a while, maybe, 50 billion years or more in some alternate timeline when physics just gives up. Galaxies would be ripped from their filaments and flung into the void. Quasars could blink out or reignite with even more terrifying brightness. The dark matter halos holding everything together would warp and flex like rubber bands snapping across space, and you might even see shockwaves ripple through the cosmic web. You know, subtle filament ripples traveling across distances so vast that we would all go extinct and the sun would live 10 lifetimes before the signal arrives. The energy release? Easily at least 10 to the 60 joules. That is so incomprehensibly huge it wouldn't even explode because a lot of things wouldn't actually collide, but it would just restructure the entire framework of the universe. Not a bang, a reformat. Congratulations, Kyle, you've just watched the largest possible collision that physics allows. You know, theoretically. And just when you thought we were done, the final boss appears. Yes, there are even larger things than this. The super voids. No stars, no galaxies, no filaments, just emptiness. Meet the Boötes void and the KBC void. Places in the universe where stuff forgot to exist. If two of these ever overlapped or collided, nothing would crash, nothing would explode. The darkness would just grow, like the monsters from your sleep paralysis, Kyle. Filaments surrounding them would stretch, dilute, and vanish around it as it would push all other objects into each other over trillions of years. Gravity would lose control and cease to have impact, and the last light would die, in silence. Not with a bang, but with nothingness. And maybe, just maybe, you'd see a Boltzmann brain at the end of time.